spectrophotometer, it may be NMR spectrophotometer, whatever the spectrophotometer we are using, that for the operation of that instrument, a trained person is required. And the third disadvantage of this, the expert required for the interpretation of the data. So in order to interpret the data which is obtained from different instrument, there is a requirement of an expert person. While in chemical method, everybody can interpret. Everybody can interpret whatever the observation we are getting by doing the different tests, that can be interpreted very easily. But when the spectroscopic methods are used, it will require a expert in order to interpret the data. Now, the second point is the spectrometer. It is an instrument that can measure the radiation intensity as a function of energy E, frequency, wavelength, wave number in order to obtain a spectrum. What is meant by spectrometer? It is an instrument. Spectrometer is nothing but it is an instrument which measures the radiation intensity. So when the electromagnetic radiations are incident on a matter, when the electromagnetic radiations are incident on a matter, the instrument which we are using in the spectroscopy, it measures the radiation energy as a function of energy, frequency, wavelength, wave number in order to obtain a spectrum. And what is spectrophotometer? It is used, a spectrophotometer that uses a photon detector, in which there is a presence of photon detector to measure the ratio of incident radiation and emerging radiation on a sample as a function of wavelength, frequency, and wave number. So the spectrometer and spectrophotometer, these are the instrument. Spectrometer is the instrument, while the spectrometer is also instrument. It is used to which uses the photon detector. Now the second point, that is classification of spectroscopy. Spectroscopic method or spectroscopic measurement is on the basis of either energy absorbed or emitted. What is done in spectroscopic method? When the electromagnetic radiations are incident on a matter, when the electromagnetic radiations are incident on a matter, what happened with a matter? The electromagnetic radiation, it may be either absorbed or it may be either emitted. So spectroscopic method is on the basis of either the energy is absorbed or it is emitted by the matter. When you incident any radiation on a matter, what will be the changes takes place? Either the radiation in the energy in the form of radiation, it will be absorbed or it will be emitted. It will be emitted. So this is the spectroscopic measurement. Spectroscopic measurement is simply, it is on the basis of either energy absorbed by the matter or it is energy emitted by the matter. So method are differentiated as either atomic or molecular. There are two type of methods. They are differentiated as either atomic, which is applied on the atom, or they are either molecular spectroscopy, which is applied on the molecules. What is meant by absorption spectroscopy? Now let us see. We have seen that spectroscopic measurement is on the basis of either energy absorbed, which gives the absorption spectroscopy, or it is either emitted, which gives the emission spectroscopy. So what is absorption spectroscopy? It uses the range of electromagnetic spectra. There is a use of certain range of electromagnetic spectrum in which a substance absorbs. That range which is absorbed by the substance, it is used for in the absorption spectroscopy. So electromagnetic radiation, if you see, it have different ranges. It have different ranges. Gamma ray, X-ray, UV visible, IR. These are the different ranges. We will go later on to this different range. So whatever the electromagnetic spectra of that electromagnetic spectra, it uses a range which is absorbed by the substance. This includes atomic absorption spectroscopy and various molecular techniques such as IR spectroscopy in that region and nuclear magnetic spectroscopy in radio region. So what it consists? It consists at absorption spectroscopy, then and various molecular techniques such as infrared spectroscopy. And what is the electromagnetic radiation used in infrared spectroscopy? That is IR region. What is the electromagnetic radiation used in NMR spectroscopy? That is radio region. So depending upon which type of region the compound uses, there is a use of which type of region, the spectroscopy, absorption spectroscopy are classified as absorption spectroscopy are classified UV visible spectroscopy, IR spectroscopy, and NMR spectroscopy. While the second point, if you see, that is emission spectroscopy. It uses the range of electromagnetic radiation, electromagnetic spectra, in which a substance radiates, it emits. So that range of electromagnetic radiation is used in the emission spectroscopy, which is emitted by the substance, which is after absorbing that radiation, the compound undergo the emission of that radiation. That range is used in the emission spectroscopy. The substance first must absorb energy. So in this spectroscopy, what is done? You see, the substance under examination first absorb the energy. This energy can be from the variety of source. This energy can be from the variety of the source, which determines the name of the subsequent emission, like luminescence. Molecular luminescence technique include spectropluorometry. So in emission spectroscopy, the compound absorbs the radiation, and this absorbed radiation is then emitted by the compound, by the molecule, and hence this spectroscopy is known as a emission spectroscopy. It is known as a emission spectroscopy. So after seeing the spectroscopic method, let us come to the next, that is concept of energy. It is not included in your syllabus. Then secondly, we will go to electromagnetic radiation. As we know that spectroscopy is the method in which the electromagnetic radiation are interacted with the matter. So you must know what is meant by electromagnetic radiation. So electromagnetic radiation, production of electromagnetic radiation and its propagation through space and its interaction with other matter is explained by using wave model and particle model. It is explained by using wave model and particle model. Let us go. It is not necessary there to see what is meant by wave model. Let us go directly to the EMR, electromagnetic radiation. The electromagnetic radiation, as I have already shown on the PPT, you see, the electromagnetic radiation have two fields which are at a right angle to each other and are perpendicular to the direction of propagation. You see, if you see the figure, whatever present on the PPT, what I say that there are two fields. First is a magnetic field and second is the electric field. Magnetic field and electric field. If you see the magnetic field travels like this. This is the traveling of the magnetic field. This is the traveling of magnetic field. While if you see the electric field, the electric field travels like this. So both these fields, thank you, sir. Both these fields, which is a magnetic field and electric field, they are traveling right angle to each other, perpendicular to the each other. Right angle to each other, and they are perpendicular to the direction of propagation. This is the direction of the propagation. I have shown on the PPT. This is the direction of propagation. If you see the magnetic field and electric field in electromagnetic radiation, the electromagnetic radiation. So its name itself indicates that electromagnetic radiation. It consists two type of fields. First one is a magnetic field and second one is the electric field. the electric field and magnetic fields are right angle to each other, and they are traveling perpendicular to the direction of propagation. So this is the magnetic field. So as you see, this is the electric field. The red, I have shown by the red lines, this is the electric field, while this blue line which is there on your PPT, this is a magnetic field, and they are at a right angle to each other, and they are perpendicular. You see, this is the perpendicular to the direction of the propagation. So hence, as they contains both magnetic field and electric field, they are known as electromagnetic radiation. They are known as electromagnetic radiation. समजते का तुम्हाला? हॅलो, अरे तुम्हाला ऐकायला येत ना सगळ्यांना?
हो येते.
आता हे electromagnetic radiation, the students which are belonging from the physics particularly, or which have passed their 12th science from the physics, they are very much familiar with the electromagnetic radiation. So the parameter which characterize the electromagnetic radiation, what are the different parameters which is there with which are associated with the electromagnetic radiation? First one is the amplitude, second one is the wavelength, and third one is the frequency. So these are the three important characters. Madam, these are the three important characters which are there for which are with the electromagnetic radiation. The first one is amplitude, second one is the wavelength, and third one is the frequency. Now you see, what is meant by amplitude? What is meant by amplitude? This is how high the wave, how high, what is the high, how much height of the wave, that is nothing but amplitude. So I have written here, the maximum displacement of the wave from the propagation, you see here, if you start, this is the line of propagation, you see, this is the wave which is a traveling, so this distance from this propagation to this is the maximum displacement, from the propagation. This distance, this is the a distance, this distance is known as the amplitude of the wave. This is known as the amplitude of the wave. Now we see the second point. What is meant by amplitude? The maximum displacement of the wave. If you see, this is the line of propagation. And if you see this is the wave. How much? This is the maximum displacement. If the displacement is at this point, the arrow will be extended up to this. But you see, this is the arrow which shows the maximum displacement. This is denoted by letter A. And this A is nothing but amplitude. This distance is nothing but amplitude. So maximum displacement of the wave, it is known as a amplitude. Now second, if you see, this is the wavelength, which is denoted by letter lambda. This is the distance between two corresponding points on the wave and is measured in meter. It is measured in meter. So into bracket I have written the distance between two successive crest or trough. So this is the first point and this is the second point on the wave. This is the first point and this is the second point on the wave. This distance between 2 points, it is known as lambda, which is known as a wavelength. Or this is first point, this is the second point. The distance between these 2 points, it is known as a lambda. Or this is the this is 1 point and this is second point. The distance between these 2 points, it is known as a lambda, that is wavelength. So this is the distance between two corresponding points on the wave and it is measured in meter, or this is distance between two successive crest or trough. Then the third point, that is frequency. The number of cycles of wave passing through a fixed point per unit time. The number of cycles of, this is the one cycle. You see, if you start from this and go up to this is the one cycle. So number of cycle passing through a fixed point. Suppose you see this is the fixed point. How many number of waves passing through this point per second, that is nothing but frequency, and it is measured in hertz. It is measured in hertz or megahertz. It is measured in hertz or megahertz. So these are the three important characteristics which are associated with the electromagnetic radiation. The first one is known as amplitude, the second one is known as a wavelength, while the third one is known as a frequency. Now you see, you will get the clear cut idea by seeing this figure. So if you see the electromagnetic waves, I have shown here. These are the waves which are traveling. This is the waves which are traveling. This is the propagation of the wave. This is the propagation, direction of travel. The waves are traveling from this side to this side. This is the direction of travel. Now you see, this is the maximum displacement of the wave. This is the maximum displacement of the wave. And this maximum displacement, which I have shown, in the figure, it is known as the amplitude. So this is the distance. This is the wave. And this wave is traveling from this direction to this direction. I have shown you direction of the travel. This is the maximum displacement known as the amplitude. Now you see, this is the maximum displacement. This displacement, it is known as a crest, and this displacement, it is known as a trough. So distance between two successive crests. This is the first crest, this is the second crest. Distance between two successive crests, it is known as a wavelength, or distance between two successive trough, it is known as a wavelength. So I have shown you here what is meant by crest and what is meant by trough. So this distance between two successive crests, our distance between two successive trough, it is known as a wavelength. And this is the movement of water molecule. That is not necessary, but you see, the electromagnetic nature of the electromagnetic is like this. There are two fields. One is an electric field and second is a magnetic field. They are perpendicular, they are at a right angle with each other and perpendicular to the propagation. They are perpendicular to the propagation. So after seeing the actual structure of the electromagnetic radiation, you will get the clear-cut idea, that is what is meant by wavelength, what is meant by crest, what is meant by trough, what is meant by amplitude. Now you see what I say. Suppose you start from this point and you goes to come to this. This is the one cycle. So how many cycles from this particular point passes per second? That is nothing but frequency of that waves, So electromagnetic radiations are characterized by amplitude, wavelength, and the frequency. So you see now, the crust is the point on wave with the maximum value. You see, this is the wave which I have seen. This is the wave which is traveling in this way. You see, this is the wave which is traveling in this way, starting from this to this point. This is the travel of the electromagnetic wave. So what is meant by crest? It is the point on wave. This is the point on the wave with a maximum value or upward displacement within the cycle. This is the ones I have shown the cycle. Suppose you have seen this and this. This is one cycle starting from this to this. This is the one cycle. So this is the maximum displacement in upward direction. Of the cycle, it is known as a crest. Or trough is a opposite of the crest. It is the opposite. Suppose this is the line of propagation. Trough is the opposite of the crest, and so the minimum or the lowest point of the cycle. If you see this cycle, it is the minimum or lowest point of the cycle. So cycle is nothing but starting from this. Suppose you start from this, and if you go up to this, this is a one cycle. And how many cycles passes through this particular point per second? It is known as a frequency of that wave. So this is nothing but it is a crest and trough. Crest is a maximum displacement of the wave in upward direction, while trough is the maximum displacement of the wave in downward direction. that is nothing but crust and truck. The distance between two crust, this is the first crust, this is the second crust. Suppose you measure distance between these two crust, or if you measure distance between, this is the one crust and this is another trough, this is one trough and this is another trough, the measure between two successive trough or two successive crust, that is known as wavelength, that is known as wavelength. So after going to this electromagnetic radiation, you will go what are the general properties of all the electromagnetic radiation. What are the general properties of all the electromagnetic radiation? So electromagnetic radiation, the first property, electromagnetic radiation can travel through empty space. It may travel through the empty space. Most other type of wave must travel through some sort of substance. Other waves requires some sort of substance. For example, sound waves need either a gas, solid or liquid to pass through it in order to be heard here, in order to be heard. Suppose you see sound waves, it requires either gaseous medium, solid or liquid to pass through in it in order to heard it. So electromagnetic is the most, it is the radiation which can travels through empty space. This is the first. The speed of the light is always constant. The speed of the light is always constant, which is given by 2.9979245 into 10 to minus meters per second. And the last characteristic of electromagnetic, the wavelength are measured between the distance of either crest or trough. It is usually characterized by the Greek symbol lambda. It is usually characterized by the Greek symbol lambda. So the next point you see, when matter excited thermally or by the nuclear process or by bombardment with other radiation, photons are emitted. Suppose you see electromagnetic radiation and it is interacted with the matter. It is interacted with the matter. What happens when the electromagnetic radiations are imparted or interacted with the matter? There is a radiation of the photons, or photons are emitted. Sorry, there is an emission of the photons. The photons moves at a speed of light. Whatever the photon emitted, that moves at a speed of the light. The photon also exists as a reflected or absorbed radiation. It may reflect, it may absorb. The amount of energy associated with the photon is nothing but E is equal to h nu, that is E is equal to, sorry, h into c by lambda, h into c by lambda, where h is a Planck's constant, the value of which is a 6.626 into 10 raised to minus 34 joule. So this is about all about the electromagnetic radiation, the characteristic of the electromagnetic radiation which we have seen during this lecture. So any doubt regarding this? Hello, am I audible to you?
Yes, sir.
Yes, sir.
काय याच्यामध्ये डाऊट आहे कोणाला? हॅलो,
नाही सर, समजले.
समजले का नक्की?
हो हो
हो.
So immediately Manwar madam will continue the lecture. Don't move, you don't leave and pay attention on lecture only. समजताय ना?
हो.
हॅलो, आपणाला काही दिवस हे करायचंच आहे, त्याच्यामुळे तुम्ही सगळ्यांनी प्रेझेंट ही आपली व्यवस्थित लावायची आहे. नंबर किती आहे बघा जरा, 107. ओके, जरा स्क्रीनशॉट कोणी घेतलाय का अटेंडन्सचा? गुरु प्रतीक्षा कदम,
हा सर.
अरे स्क्रीनशॉट घेतलाय का अटेंडन्सचा तू?
नाही घेतला, घेते सर.
जरा स्क्रीनशॉट घ्या आणि मला व्हॉट्सअप ग्रुप आपला आहे ना
आहे.
टीवायचा,
हो.
त्याच्यावर जरा पाठवून दे. ते नंबर ऑफ स्टुडंट्स आहे ना 106 107 काय आहे त्याच्या पाठवून द्या. हा
हा.
ओके ओके, समजतं का?
हो.
ओंकार जगताप,
हा
हॅलो,
सर.
समजतंय का?
हा सर.
हा, गुरव कुठे गेली? गुरव
आहे की सर आहे.
आहे ना, समजतंय का?
हो समजते.
ओके ओके, लगेच मानवर मॅडम जॉईन करतायत बघा, तुम्हाला त्यांना लगेच जॉईन व्हा. ओके.
स्क्रीन शेअर कसं करायचं कदम सर? स्क्रीन
ओपन करून ठेवा.
केलंय की केलंय open.
गुगल
कुठे गुगल?
इथे ना, इथे क्रोम
हा.
याच्यावरती क्लिक करा.
याच्यावरती का?
शेअर
शेअर म्हणा. तुमची पीपीटी ओपन केलेली? केली.
आता पीपीटीला क्लिक करा.
यू आर प्रेझेंट झालं? हो.
एकदा विचारा, स्क्रीन दिसते का?
स्क्रीन दिसते का विचार. रेकॉर्डिंग रेकॉर्डिंग बघूया की. रेकॉर्डिंगचं चालू तिथं हा आहे आहे चालू. ठीक आहे. अगोदर विचारा. एम आय ऑडिबल टू ऑल?
येस मॅम.
स्क्रीन दिसतोय का सर्वांना?
हो दिसते.
हो मॅडम.
ओके. स्लाइड शेअर करा. स्लाइड शो करायचं? हा म्हणजे मोठं. इथं असं का? पुढचं थोडस तर. ओके, we will start our paper number 9, BCT 501, physical chemistry for the semester 5. Let us consider one of the unit in this paper, that is surface chemistry. In this unit, we have to cover these points. That is the introduction about this surface chemistry, adsorption, mechanism of adsorption, factors affecting adsorption, then the types of adsorption. There are two types of adsorption, that is the physical adsorption and chemical adsorption, that is phygisorption and chemisorption. Types of adsorption isotherms, that is when we plot the graph of amount of substance adsorbed against concentration or pressure, we got at constant temperature, we got the line or a graph that is known as the isotherm. We have to see about the different types of the adsorption isotherms. In that, also we have to consider in detail Freundlich adsorption isotherm and Langmuir adsorption isotherm, its derivation. Then the BET equation and how this BET equation can be used for the determination of surface area of adsorbent. And we have to consider about the various applications of adsorption. Let us consider first, that is the introductory part of this surface chemistry. Am I audible?
Yes, ma'am.
Yes, ma'am.
आणि स्क्रीन दिसतोय ना सर्वांना?
Yes, ma'am.
Okay. During this study of the adsorption, that is the surface phenomenon, let us consider about the surface. That is, what is the surface? You know, the surface of the any substance, any object, that is, it is a boundary or interface between two media. That is, if we consider blackboard and duster, blackboard has surface, also duster has surface, that is its boundary or it is the interface between two media. It is the outermost or uppermost layer of a physical object or a space. म्हणजे कुठलाही ऑब्जेक्ट आपण, if we consider any substance, any matter, if we consider any object, its outermost part is the surface, and it is the portion or region of the object that can be first perceived by an observer using the senses of sight and touch. पहिल्यांदा आपण surface बघतो. Also we can perceive it by the sense of sight and touch, and it is the portion with which other materials first interact. म्हणजे other material त्याच्या कॉन्टॅक्ट मध्ये आला तर फर्स्ट surfaces interact होईल, and it is the uppermost layer of the matter, it is the uppermost layer of the object, it is the surface. Now what is the history of the adsorption? That is, we have to study the phenomenon of adsorption in surface chemistry topic, and since from the long time, animal charcoal attract selectively certain molecule from the mixture of gases or liquids, and also this animal charcoal is used to remove the coloring impurities from the sugar solution. That is, in the sugar solution before the crystallization, this animal charcoal removes the colored impurities from the sugar solution. Nowadays, various substances having these charcoal-like properties are used, that is the finely divided nickel, platinum, alumina, silica gel. These substances also show the charcoal-like properties, that is they also remove the certain impurities or unwanted substances from the solution, from the material. Now what is that? How these substances, unwanted impurities are removed from the solution? By adding the another substance. What happens actually? You can see this figure, that is, this is the activated charcoal. And if this activated charcoal comes in contact with another substance, that is this gas molecule, suppose it is another substance. These are the two substances, and this uppermost layer or outer layer of animal charcoal is the surface. What happens actually? This other substance attracted towards the surface of this activated charcoal and get adhered on the surface of this activated charcoal. It only adheres on the surface. It does not penetrate in the body of that activated charcoal. It only accumulates at the surface of the activated charcoal. Means what happens here? When gas molecules comes in contact with the activated water, these gas molecules are accumulated on the surface of the activated charcoal. They does not penetrate in the body of the charcoal. And therefore what happens? There is the increase in concentration of this gas molecule. इकडं स्पेस मध्ये गॅस मॉलिक्यूलचं कॉन्सन्ट्रेशन पाहिलं आणि ऍक्टिव्हेटेड चारकोलच्या सरफेस वरती कॉन्सन्ट्रेशन पाहिलं तर इथं ऑन द सरफेस ऑफ द activated charcoal, there is the greater concentration of gas molecules, and we say that these gas molecules accumulate on the surface of this activated charcoal. म्हणजेच काय झालं इथं, there is the collection of gas molecules, there is the accumulation of the gas molecules on the activated charcoal. Means this gas molecules is the other substance and charcoal is the different substance. These other substance molecules are accumulated on the surface of another substance, and that is known as the adsorption. Thus, we can define this phenomenon of adsorption as the काय definition सांगता येईल आपल्याला? It is the collection or accumulation of the another substance on the surface of solid or liquid is known as the adsorption. दुसरा सबस्टन्स ज्यावेळी accumulate होतो, कलेक्ट होतो another substance त्या surface वरती, that is known as the adsorption. This phenomenon of collection or accumulation of another substance on the surface of other substance is known as the adsorption. Understand? समजलं adsorption म्हणजे काय ते?
Yes, ma'am.
Yes, ma'am.
काय
Yes, madam.
reply येत नाही तुमचा? समजते? हा. And next, consider about the mechanism of adsorption. That is why only these molecules gets adhered on the surface of another substance. They does not penetrate in the body of that other substance. They accumulate on the surface of other substance, and for this, we have to see the mechanism of the adsorption. This slide shows the mechanism of the adsorption. All of you know that if we consider any substance that is solid or liquid, in solid, it contains the closely packed layers of atoms or molecules or ions. म्हणजे जर आपण सबस्टन्स कन्सिडर केला तर त्या सबस्टन्स मध्ये इंडिव्हिज्युअल युनिट्स आहेत. इंडिव्हिज्युअल युनिट्स कोणते आहेत? तर इंडिव्हिज्युअल युनिट्स मे बी ॲटम, इट मे बी मॉलिक्यूल और इट मे बी आयन. म्हणजे NaCl क्रिस्टल जर आपण कन्सिडर केले तर Na प्लस अँड Cl मायनस आयन्स आर इंडिव्हिज्युअल युनिट. H2O consider केला, H2O molecule is the individual unit, means atoms or molecules or ions are the individual units of the substance. Now, if we consider the bulk of that substance, the bulk आपण त्या substance interior part, bulk म्हणजे काय? Interior part जर consider केला substance चा, तर त्या interior part मध्ये surrounding ला सिमिलर मोलिक्युल्स किंवा सिमिलर ॲटम्स किंवा सिमिलर आयन्स असणार आहेत. म्हणजे बल्क ऑफ द मॅटर मध्ये हा जर ॲटम किंवा मोलिक्युल किंवा आयन आपण कन्सिडर केला तर इट वॉज इक्वली सराउंडेड बाय द सिमिलर मोलिक्युल, सिमिलर ॲटम्स और सिमिलर आयन्स. जे काही इंडिव्हिज्युअल युनिट त्या सबस्टन्स असेल त्या सबस्टन्सच्या मधील आयन, मोलिक्युल किंवा ॲटमने हा सराउंड झालेला असेल. And you all of you know about that there exists the force of attraction between these similar molecules also, that is the cohesive force. आणि हा cohesive force सर्व बाजूंनी सारखाच आहे. It is same in all the direction, and therefore we can say that these forces are satisfied. कधी जर बल्क मधला पार्टिकल, बल्क मधला युनिट आपण कन्सिडर केला, that unit was equally surrounded by the another similar unit, and therefore the resultant force of attraction on this is 0, and we can say that the forces are in the bulk of the solid. These attractive forces are satisfied. But instead of these, if we consider the surface molecule, जर आपण सरफेसचा मोलिक्यूल कन्सिडर केला मॅटर मधला, तर या सरफेसचा कन्सिडर दॅट दिस इज द सरफेस मोलिक्यूल. हे जे सरफेसला मोलिक्युल्स दाखवलेले आहेत हे मोलिक्यूल जर आपण कन्सिडर केले तर there was the another molecule in the interior part of the substance. त्याच्या फक्त आतल्या बाजूला सिमिलर मॉलिक्युल्स आहेत, बाहेरच्या सरफेसच्या बाहेरच्या बाजूला त्याचे मॉलिक्युल्स नाहीत. म्हणजेच फक्त आतल्या बाजूला याची व्हॅलन्सी किंवा याचं जे फोर्स ऑफ अट्रॅक्शन असेल हे इट इज ऍक्टिंग इन द इनवर्ड डायरेक्शन अँड देअरफॉर द आउटरमोस्ट लेयर इट्स फोर्सेस आर नॉट सॅटिस्फाईड. इथं त्याच्याशी these forces on the upward side there are no neighboring molecules and therefore we can say that there exist the residual forces on the upper side at the surface molecule. कारण याच्याशी बाइंड झालेलं नाही neighboring molecule means these forces are unsatisfied forces, or also we can say that these forces are residual forces. म्हणजे हे जे फोर्सेस आहेत याला आपण रेसिड्युअल फोर्सेस म्हणू शकतो किंवा these forces are unsatisfied forces. कारण या सरफेस मॉलिक्युलच्या वरती नेबरिंग मॉलिक्युल त्याच टाईपचा नाही की जो त्याच्याबरोबर फोर्स ऑफ अट्रॅक्शन exert करतोय, and therefore we can say that their valency is unsatisfied, or there are the residual forces, or there are the unsatisfied forces at the surface of the substance. म्हणजे का unsatisfied आहेत तर surface molecules are not attracted on all sides as the surface is vacant, and therefore these forces are unsatisfied forces. We say that these are the residual forces. या अनसॅटिस्फाईड फोर्सेसलाच आपण काय म्हणतो, रेसिड्युअल फोर्सेस. मग काय कुठलाही सबस्टन्स करेल तर त्याचे फोर्सेस हे सॅटिस्फाय करण्याचा प्रयत्न करेल, आणि त्यासाठी मग काय करेल हा सरफेस मॉलिक्यूल, जेव्हा त्याच्या कॉन्टॅक्ट मध्ये दुसरा अनदर सबस्टन्स येईल, त्या सबस्टन्सचे तर मॉलिक्यूल नाहीत अट्रॅक्ट करण्यासाठी, मग त्याच्या कॉन्टॅक्ट मध्ये दुसरा अनदर सबस्टन्स आला तर या अनदर सबस्टन्सला तो काय करेल, अट्रॅक्ट करेल. म्हणजेच सरफेस पार्टिकल ट्राय टू सॅटिस्फाय देअर फोर्सेस बाय अट्रॅक्टिंग अँड रिटेनिंग अदर सबस्टन्स ऑन इट्स सरफेस. दॅट इज द अडेसिव्ह फोर्स. अडेसिव्ह फोर्स म्हणजे काय, force of attraction between two different substances. Surface due to unsatisfied forces, due to residual forces, when another substance comes in contact with this surface, it attracts that another substance, and that another substance will adhere on the surface of this substance, and this is known as the adsorption. That is the actual adsorption process. Understand this mechanism of adsorption? समजलं?
येस मॅडम.
काय डिफिकल्टी आहे का याच्यामध्ये?
नाही मॅडम.
Then we will proceed further. जर तुम्हाला समजलं असेल तरच आपण पुढे जाऊया. समजलंय का सर्वांना?
हो.
आवाज काय फार हळू येतोय. Then next, this slide shows the example of the adsorption. That is the animal charcoal when mixed in the dye. डाय सोल्युशन आपण कन्सिडर केलं मिथिलीन ब्ल्यूचं, आणि त्याच्यामध्ये जर अॅनिमल चारकोल किंवा चारकोल पावडर, ऍक्टिव्हेटेड चारकोल पावडर ऍड केली, कन्सिडर दॅट इन ए टेस्ट ट्यूब देअर इज द मिथिलीन ब्ल्यू डाय सोल्युशन, ब्ल्यू कलर, आणि या टेस्ट ट्यूब मध्ये अॅनिमल चारकोल पावडर तुम्ही ऍड केली आणि सेट केलं, थोडा वेळ टेस्ट ट्यूब तशीच राहू दिली, तर यू नोटिस दॅट कलर ऑफ द सोल्युशन बिकम्स फेड. जो टेस्ट ट्यूब मधील सोल्युशनचा कलर असतो तो सोल्युशनचा कलर फेंट होतो. काय हे होतं तर सोल्युशन मध्ये असणारे मेथिलीन ब्ल्यू डायचे जे मॉलिक्युल्स आहेत ते मॉलिक्युल्स चारकोलच्या सरफेस वरती काय झाले, ऍडसॉर्ब झाले. म्हणजे सोल्युशन मध्ये असणारे नंबर ऑफ मॉलिक्युल्स कमी झाले आणि त्यामुळे त्याचा कलर हा काय होतो, फेंट होतो. मीन्स इफ वी ऍड चारकोल पावडर इन मिथिलीन ब्लू सोल्युशन, इट्स कलर becomes faint, and it is why it happens. It happens due to the adsorption, that is the molecules of the dye are adsorbed on the surface of the charcoal. That is this figure shows that these molecules are adsorbed on the surface of this charcoal. That is the substance being adsorbed is known as the adsorbate, and the charcoal, that is the surface on which that substance is adsorbed, that substance charcoal is known as the adsorbent. Familiar example आपण कन्सिडर केला, दॅट इज इफ वी कन्सिडर द चॉक कन्सिडर केला आपण आणि तो इंक मध्ये डीप केला, तर यू ऑब्झर्व दॅट इंक पार्टिकल्स आर ऍडसॉर्ड ऑन द सरफेस ऑफ द चॉक, आणि तो चॉक जर पुन्हा तोडला तर त्याच्या आतील बाजूला तो चॉक व्हाईटच दिसतो. म्हणजेच दिस इज द सरफेस फिनॉमिना, नॉट द बल्क फिनॉमिना. This is the example of the adsorption, that is the adsorbent atoms or molecules are not surrounded by atoms or molecules of their kind. आता इथे adsorbent कोणता आहे, चारकोल आहे, त्याच्याच सारख्या atoms ने किंवा molecules ने तो surround झालेला नाही. Therefore they have unbalanced attractive forces on the surface. When another substance comes in contact with that, it can hold that substance on the surface. That is known as the adsorbate. We have seen the example. Then consider that in both these phenomena are known as the sorption. But there is a difference between adsorption and absorption. काय डिफरन्स आहे दोन्ही मध्ये, ऍडसॉर्प्शन आणि ऍब्सॉर्प्शन मध्ये? तर इन केस ऑफ द ऍडसॉर्प्शन वी हॅव सीन दॅट व्हेन another substance comes in contact with the substance, we have seen it is the surface phenomena, and on the surface it has residual forces or unsatisfied forces, and when other substance comes in contact with that, it attract the particles of that other substance. Means this phenomena occurs between two heterogeneous phases, that is the gas solid, liquid solid, gas liquid. This phenomenon is a surface phenomena, that is the molecules of other substance does not penetrate in the body of the adsorbent. जर चारकोल पावडर आपण कन्सिडर केली, we have seen the example, that is when charcoal powder is added in the methylene blue solution, these particles are adsorbed on the surface. These are not penetrate in the body of that substance, and thus the adsorption is the surface phenomenon. It is the accumulation of other substance on the surface of the another substance. म्हणजे इथं दोन्ही एकाच प्रकारचे सबस्टन्स नाहीत, तर दोन वेगवेगळ्या प्रकारचे सबस्टन्स आहेत. दॅट इज द these two phases are heterogeneous phases. We have seen about this, that is which is the adsorbent and which is the adsorbate. Then if we consider the absorption, adsorption is surface phenomena, but when we dip sponge in water, what happens? The water will penetrate in the body of sponge and gets uniformly distributed in the body of that another substance. Is it does not accumulate on the surface, it penetrates within the body of the substance and get uniformly distributed. It is the bulk phenomena. Means absorption is the bulk phenomena, in this figure, this substance is the adsorbent and another substance which is being adsorbed on the surface of that substance is known as the adsorbate. It is the surface phenomena. But if we observe this figure, that substance will penetrate in the body of that substance. Also, this figure indicates that in adsorption, molecules of the other substance accumulate on the surface of that substance. But in case of the absorption, these molecules penetrate in the body of the substance and gets uniformly distributed in the body of that substance. That is the absorption. How we can differentiate between this adsorption and absorption? आपण पाहिलं की adsorption ही surface phenomenon आहे, absorption ही bulk phenomenon आहे. That is, from that we can differentiate adsorption and absorption. That is, adsorption is the surface phenomenon, while the absorption is the bulk phenomenon. In case of the adsorption, also we can state another difference, that is the adsorbed substance collected on the surface of another substance. जो substance adsorbed झालेला आहे दुसरा substance, तो त्या सबस्टन्सच्या सरफेस वरती कलेक्ट झालेला आहे, त्या दुसऱ्या सबस्टन्सच्या सरफेस वरती accumulate झालेला आहे. That is the adsorbed substance collected on the surface of the another substance. In case of the absorption, what happens? That another substance which is absorbed is not only collected, it is not collected at the surface, it is penetrated in that substance and gets uniformly distributed within the body of that substance. Means adsorbed substance is uniformly distributed in another substance. Adsorption is the exothermic process. All of you know that exothermic and endothermic process, that is, in exothermic process, heat is evolved, while this absorption is the endothermic process. Adsorption depends upon the temperature and pressure. We will see these in the factor affecting the adsorption. That is how the temperature and pressure affect the adsorption. But absorption does not depend upon the temperature and pressure. Adsorption हे temperature आणि pressure वरती depend असतं, परंतु absorption it does not depends upon the temperature and pressure. Adsorption depends upon the unsaturated molecules or atoms on the surface. म्हणजे एखाद्या सबस्टन्सच्या सरफेसला जास्त अनसॅच्युरेटेड मोलिक्युल्स किंवा ॲटम्स असतील तर देअर विल बी द greater adsorption. Means it depends upon the unsaturated molecules or atoms on the surface, but absorption depends upon the porous nature of the substance. Example, we have seen the different examples of the adsorption. That is, adsorption of methylene blue by charcoal, adsorption of acetic acid by charcoal, adsorption of hydrogen by platinum. These are the examples of the adsorption. You know the different examples of the absorption. That is the absorption of water by sponge. Then let us consider about the factors affecting the adsorption. There are different factors which affect the adsorption. पण पाहिलं आतापर्यंत की adsorption म्हणजे काय आणि difference between the adsorption and absorption. What is mean by adsorbent and adsorbate? Adsorbent म्हणजे काय? If we consider the adsorption of acetic acid by charcoal, then acetic acid is the adsorbate and charcoal is the adsorbent. There are different factors which affect the adsorption. These are the different factors which affect the adsorption, that is the nature and surface area of the adsorbent. Nature of the adsorbed gas, temperature, pressure on the gas, heats of adsorption, a reversible character, and adsorption is the selective or preferential process. Let us consider one by one. Am I audible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
हा, आणि स्क्रीन दिसतोय ना सर्वांना?
Yes.
हा. Then consider nature and surface area of the adsorbent. Adsorbent is the adsorption is the surface phenomena, and therefore the extent of adsorption depends upon the surface area. We have seen that is the adsorption is the surface phenomena. That is the greater is the number of molecules or atoms on the surface whose balances are unsatisfied, whose forces are unbalanced forces, then greater will be the adsorption. As it is the surface phenomena, the extent of adsorption depends upon the surface area. That is, if we increase the surface area of the adsorbent, it will increases the total amount of gas adsorbed. How the surface area is increased? That is, if we consider that is the finely divided metals like nickel, platinum, its surface area is higher and it will adsorb greater number of molecules or another atoms or ions of another substance, and therefore the adsorption will increase. Means with increase in surface area, that is more finely divided the adsorbent, then its surface area increases and therefore the extent of adsorption also increases. Also the porous nature of the substance will also provide the large surface area. म्हणजे finely divided and porous nature of the substance provides large surface area and therefore greater will be the adsorption. That is, larger the surface area, greater will be the adsorption. It is the first factor which affect the adsorption, nature and surface area of the adsorbent. Next, consider the nature of adsorbed gas. If we consider the adsorption of adsorption of gas by solid, then the amount of gas adsorbed by a solid, it will depends upon the nature of the gas. In general, more easily liquefiable is the gas. That is, higher its critical temperature, the more readily will it be adsorbed. What is critical temperature? काय क्रिटिकल टेम्परेचर म्हणजे? अँड्रूज आयसोथर्म मध्ये तुम्ही पाहिलेलं आहे, गॅसियस स्टेट मध्ये स्टडी केलेलं आहे. व्हॉट इज क्रिटिकल टेम्परेचर? We have to liquefy the gas. We have high pressure. And आणखी काय
टेम्परेचर
करावं लागेल? हा, आवाज येतोय का? लिक्विफिकेशन ऑफ गॅसेस तुम्ही स्टडी केलेला आहे. अँड्रूज आयसोथर्म 12th मध्ये स्टडी केलेला आहे. व्हॉट इज द क्रिटिकल टेम्परेचर? It is the temperature above which gas cannot be liquefied by applying any high pressure. That is the critical temperature. The more readily when the gas adsorb, if its critical temperature is higher. In general, more easily liquefiable gases are adsorbed easily. For example, if we consider that is the 1 gram of activated charcoal as adsorbent, it will adsorb 300 of sulfur dioxide. Its critical temperature is 157 degree centigrade. Sulfur dioxide, SO2, is easily liquefiable gas and therefore it is adsorbed more. But it will absorb only 16 ml of methane as critical temperature is low. Critical temperature of methane is minus 83 degrees centigrade. And only 4.5 ml of hydrogen. Its critical temperature is minus 20 degree centigrade. That is lower critical temperature, lower that gas will not be easily liquefied and the amount of such gas adsorbed is less. म्हणजे जर सल्फर डायऑक्साईडचं एक्झाम्पल घेतलं त्याचं क्रिटिकल टेम्परेचर हायर आहे 157 degree centigrade and its amount is adsorbed is higher. 180 ml of sulfur dioxide gas is adsorbed by only 1 gram of activated charcoal. म्हणजे इथं अमाऊंट adsorbentचं सेम ठेवलेलं आहे. 1 gram of charcoal adsorbs 380 ml sulfur dioxide, then 16 ml methane and 4.5 ml of hydrogen. Means example indicates that the amount of gas adsorbed depends upon the nature of the adsorbed gas. कुठला गॅस adsorb केलेला आहे त्या गॅसच्या नेचर वरती सुद्धा किती अमाऊंट झालेलं आहे हे डिपेंड आहे. Adsorption on the other hand is much more specific than the physical adsorption. We will see about that in next lecture. Consider about the effect of temperature.
मोबाईल मी नाही खेळत.
माईक ऑन आहे कुणाचं तरी म्यूट करा बॅकग्राऊंडचा आवाज येतो.
आणि
म्हणून स्टॉप केलं.
विंडो म्हणायचं का एंटर स्क्रीन असं दिसतं का स्लाइड शो करायचा मग कसं करायचं आपण बोलतोय तोपर्यंत असते का ते संपल्यानंतर होते का Am I audible?
येस मॅम.
हा स्क्रीन दिसतोय ना सर्वांना
हो.
स्क्रीन बरं स्क्रीनशॉट काढा प्रेझेंटीचा आणि आपल्या ग्रुपवर पाठवा Let us consider the next factor. We have seen about the nature of adsorbent and nature of the adsorbed gas. That is the how they affect the extent of adsorption. That is the nature of adsorbent and surface area of the adsorbent. Greater the surface area of the adsorbent, more will be the adsorption. And also we have seen that nature of adsorbed gas, that is more easily liquefiable is the gas, more will be the extent of adsorption. That is higher the critical temperature of the gas, extent of adsorption will be greater. Then let us consider the next factor, that is the effect of temperature. Physical adsorption occurs rapidly at low temperature and decreases with increasing temperature. That is the Le-Chatelier's principle. You have studied in the 12th standard. That is, we will see later physical adsorption and chemical adsorption. In adsorption, that is when the another substance is hold down the surface by weak van der Waals forces of attraction. That adsorption is the physical adsorption. म्हणजे जे फोर्सेस आहेत ऍडसॉर्बंट आणि ऍडसॉर्बेट मधले ते फोर्सेस फिजिकल फोर्सेस आहेत van der Waals फोर्सेस ऑफ अट्रॅक्शन आणि या ऍडसॉर्प्शनला काय म्हणायचं फिजिकल ऍडसॉर्प्शन. When the force there is the formation of bond between adsorbate and adsorbent, that is the chemical adsorption or chemisorption. That is physical adsorption occurs rapidly at low temperature and decreases with increasing temperature. Physical adsorption means in the types of adsorption we will see in detail about the physical adsorption and chemical adsorption. What is the effect of temperature? Physical adsorption मध्ये मी सांगितलं की adsorbate molecule are held on the surface of adsorbent by weak van der Waals forces and it occurs rapidly at low temperature, decreases with increasing temperature. In chemisorption, it generally increases with temperature. केमिसॉर्प्शन मध्ये काय होतं ऍडसॉर्बेट आणि ऍडसॉर्बंट मध्ये बॉन्ड फॉर्मेशन होतं केमिकल बॉन्ड फॉर्मेशन अँड इट विल इन्क्रीजेस with the temperature. Thus, a rise in temperature can often cause physical adsorption to change to the chemisorption. For example, nitrogen is physically adsorbed on iron at 190 degrees centigrade, but chemisort to form nitride at 500 degrees centigrade. That is the effect of temperature. Adsorption occurs at low temperature. Next, effect of pressure. Since a dynamic equilibrium exists between the adsorbed gas and the gas in contact with the solid, Le-Chatelier's principle is applied. Dynamic equilibrium means what is the static equilibrium and dynamic equilibrium? You know about the equilibrium. What is equilibrium? Equilibrium म्हणजे काय? पण मी तुम्हाला रिव्हर्सिबल रिएक्शन सांगते. A gives B. A gives B and B again reacts back to give A. That is the reversible reaction. म्हणजे आपण रिएक्शन कन्सिडर केली. ए हा रिएक्टंट आहे फॉरवर्ड रिएक्शन मध्ये. ए रिएक्ट होऊन त्याच्यापासून बी तयार झालेला आहे आणि बॅकवर्ड रिएक्शन मध्ये बी पासून पुन्हा ए मिळालेला आहे. म्हणजे these two reaction takes place simultaneously. At first what happens? The rate of forward reaction is higher than the rate of backward reaction. But as time changes, the rate of two reactions becomes equal. That is rate of forward reaction and rate of backward reaction in a reversible reaction becomes equal at some instant. And we say that the equilibrium is attained. Now, what is the dynamic equilibrium? Static equilibrium and dynamic equilibrium. याच्यामध्ये इक्विलिब्रियम अटेन झालेलं आहे. रेट ऑफ फॉरवर्ड रिएक्शन आणि रेट ऑफ बॅकवर्ड रिएक्शन सेम झालेलं आहे. तरी सुद्धा कॉन्सन्ट्रेशन रिमेन्स सेम बट द रिएक्शन इज स्टील गोइंग ऑन. म्हणजे रिएक्शन ही चालूच असते, चेंजेस चालूच असतात केमिकल. दॅट इज द डायनॅमिक इक्विलिब्रियम and it exists between the adsorbed gas and the gas in contact with the solid. There is the existence of the dynamic equilibrium between adsorbent and adsorbate. जो गॅस ऍडसॉर्ब झालेला आहे त्याला आपण काय म्हणतोय? ऍडसॉर्बेट. आणि ज्या सबस्टन्स वरती तो ऍडसॉर्ब झालेला आहे दॅट इज द ऍडसॉर्बंट. देयर एक्झिस्ट ए dynamic equilibrium between adsorbate and adsorbent. Actually, what happens when we increase the pressure? Then what happens? Adsorption will increases or decreases. काय होईल जर प्रेशर आपण वाढवलं तर adsorption increase होईल का decrease होईल?
Increase होईल.
What is the effect of pressure? The gas is in contact with the solid. When we increase the pressure on the gas, what happens? काय नाही सांगताय कुणाला? ऍडसॉर्प्शन इन्क्रीज होईल का डिक्रीज होईल? गॅस हा सॉलिडच्या कॉन्टॅक्ट मध्ये आहे. कन्सिडर करा की सॉलिड तुमचा चारकोल आणि किंवा प्लॅटिनम आहे फाईनली डिवायडेड आणि त्याच्या कॉन्टॅक्ट मध्ये हायड्रोजन गॅस आहे. हायड्रोजन गॅसवरचं प्रेशर आपण वाढवलं तर काय इफेक्ट होईल?
It will be increase.
It will be increase. Good. What happens? More and more number of gas molecules comes in contact with the adsorbent surface. Adsorbent surface च्या कॉन्टॅक्ट मध्ये जास्तीत जास्त गॅस मॉलिक्युल्स येतील and therefore the rate of adsorption will be increased. That is, if we increase the pressure on the gas, then adsorption increases. Here, I have mentioned that there exists a dynamic equilibrium between adsorbed gas and the solid. Forward reaction कोणती आहे तर gas is adsorbed on the solid surface. आणि मग बॅकवर्ड रिएक्शन काय असेल? आवाज जरा थोडा वेळ. माळी मॅडम प्लीज जरा थोडस. व्हॉट हॅपन्स? अगदी थोडाच वेळ राहिला आता. व्हॉट विल हॅपन? बघा, फॉरवर्ड रिएक्शन मध्ये गॅस इज ऍडसॉर्ब्ड ऑन द सॉलिड. मी जनरल एक्झाम्पल तुम्हाला सांगितलं. ए गिव्स बी अँड बी अगेन गिव्स ए. द फॉरवर्ड रिएक्शन आपली काय आहे तर ऍडसॉर्प्शन आहे. गॅस इज ऍडसॉर्ब्ड ऑन द सॉलिड. दॅट इज द फॉरवर्ड रिएक्शन. इक्विलिब्रियम, देअर एक्झिस्ट इक्विलिब्रियम. मग बॅकवर्ड रिएक्शन काय असेल? गॅस ऍडहर्ट झालेला आहे सॉलिड सरफेस वरती
डिसऑप्शन
बॅकवर्ड मध्ये काय होईल?
डिसऑप्शन
डिसॉर्शन. म्हणजेच काय, जो गॅस ऍडसॉर्ब झालेला आहे सॉलिड सरफेस वरती, दॅट गॅस मॉलिक्युल्स डज नॉट रिमेन्स परमनंटली देअर. इट गेट्स डिटॅच्ड फ्रॉम द सरफेस ऑफ द सॉलिड. सॉलिडच्या सरफेस पासून हे मॉलिक्युल्स काय होतात? डिटॅच होतात. दॅट इज नोन ॲज द डिसॉर्शन. दॅट इज द बॅकवर्ड प्रोसेस. म्हणजे ऍडसॉर्शन आणि डिसॉर्शन याच्यामध्ये इक्विलिब्रियम आहे. जर प्रेशर डिक्रीज झालं, इट विल कॉजेस द distortion. Thus, there exists the dynamic equilibrium between them. Adsorbed molecules of the gas or adsorbed gas does not remain permanently on the solid surface. After some time, it gets detached from the surface of the solid and it is known as the distortion. म्हणजे ऍडसॉर्शन ही इरिव्हर्सिबल प्रोसेस आहे का रिव्हर्सिबल?
रिव्हर्सिबल.
इट इज ए रिव्हर्सिबल. गुड. ऍडसॉर्शन इज द रिव्हर्सिबल प्रोसेस. समजला इफेक्ट ऑफ प्रेशर. आणि याच्यावरून पण आपण इफेक्ट ऑफ टेम्परेचर सांगू शकतो. म्हणजे फिजिकल आणि केमिकल ऍडसॉर्शन मध्ये इथे मी मेन्शन केलेलं आहे की व्हॉट हॅपन्स ड्यू टू द राईज इन टेम्परेचर. But also, in case of the adsorption, what is the effect of temperature? Adsorption generally increases at low temperature because it is an exothermic process. Exothermic process means it is evolved, and therefore adsorption is higher at low temperature. But what happens at higher temperature? Higher temperature ला काय होईल? Desorption होईल. म्हणजे reversible process takes place. That is, the adsorbed gas molecules gets detached away from the solid surface, and that is known as the desorption. What is mean by the heat of adsorption? Next factor, that is, or also we can say these are the characteristics of the adsorption. Heats of adsorption. Heat of adsorption. काय डेफिनेशन सांगता येईल हीट ऑफ ऍडसॉर्प्शनची? हीट ऑफ आयोनायझेशन, हीट ऑफ न्यूट्रलायझेशन यू हॅव सीन इन द BSc part first or also in the 12th standard. Heat of adsorption. It is defined as the energy or heat liberated when 1 gram mole of a gas is adsorbed on the solid surface. काय डेफिनेशन आहे हीट ऑफ ऍडसॉर्प्शनची? हीट इज इव्हॉल्ड ऑर लिबरेटेड, गिवन आउट. म्हणजे काही देर इज adsorbate molecule are held on the surface of the adsorbent by physical force of attraction, that is the van der Waals force, or by formation of bond between adsorbent and adsorbate, that is the chemical force, chemical adsorption or chemisorption. ज्यावेळी हे दुसऱ्या सबस्टन्सचे मॉलिक्यूल सरफेस वरती हेल्ड केले जातात त्यावेळी त्याच्यामध्ये फोर्स ऑफ अट्रॅक्शन, फिजिकल फोर्स असेल किंवा केमिकल फोर्स असेल, आणि याच्यासाठी एनर्जी काय केली जाते, हे ज्यावेळी घडून येतं फिजिकल ऍडसॉर्प्शन किंवा केमिकल ऍडसॉर्प्शन, हीट इज इव्हॉल्व्ड. व्हाय हीट इज इव्हॉल्व्ड और व्हाय द ऍडसॉर्प्शन इज एक्झोथर्मिक प्रोसेस? का होत असेल हीट इव्हॉल्व? मी तुम्हाला सांगितलं की सरफेसला नक्की काय होतं, फिजिकल फोर्सेस ऑफ अट्रॅक्शन हे दोन वेगवेगळे मॉलिक्युल सेल्ड केले जातात किंवा केमिकल फोर्सेसने, आणि हीट इव्हॉल्व केली जाते. हे तुम्ही सर्च करायचंय. Why the adsorption is exothermic process? Next lecture मी विचारणार आहे. Heat of adsorption is defined as heat evolved when 1 gram mole of the adsorbate is adsorbed on the solid surface. In physical adsorption, gas molecule concentrate on the solid surface. That is, it is the condensation of the gas on the solid. or condensation of gas on the surface of the liquid. Mug adsorption is the exothermic process because attraction between gas molecules and solid surface are due to the relatively weak van der Waals forces, and heats of adsorption is very small, that is about 5 kilocalorie, 5 to 10 kilocalorie per mole. Kadi in case of the physical adsorption. Physical adsorption मध्ये adsorbate आणि adsorbent. आता इथं आपण गॅस सॉलिड सिस्टीम एक्सप्लेनेशन साठी कन्सिडर केलेले. या गॅस सॉलिड सिस्टीम मध्ये गॅस आणि सॉलिड मध्ये फिजिकल फोर्स ऑफ अट्रॅक्शन, दॅट इज द van der Waals फोर्स ऑफ अट्रॅक्शन तयार होतो. म्हणजेच हा वीक फोर्स ऑफ अट्रॅक्शन आहे आणि याच्यामध्ये जी हीट इव्हॉल्व होते ती हीट अगदीच कमी आहे, दॅट इज 5 to 10 किलो कॅलरी पर मोल. म्हणजे हीट ऑफ ऍडसॉर्प्शन इन फिजिकल ऍडसॉर्प्शन इज स्मॉल and its value is 5 to 10 kilocalorie per mole. In chemisorption, the attractive forces are due to the formation of two chemical bonds between adsorbent and adsorbate. Chemisorption मध्ये मात्र जे फोर्सेस ऑफ अट्रॅक्शन आहेत, म्हणजे ऍडसॉर्बेट आणि ऍडसॉर्बंट मध्ये जे फोर्स ऑफ अट्रॅक्शन आहेत त्या दोन्ही मध्ये केमिकल बॉन्ड तयार झालेला आहे. हा केमिकल बॉन्ड हा स्ट्रॉंग आहे, म्हणजे अट्रॅक्टिव्ह फोर्सेस आर व्हेरी स्ट्रॉंग अँड देअरफॉर द हीट ऑफ ऍडसॉर्प्शन इज लार्ज, अबाउट 20 to 100 kilocalorie per mole. What is the heat of adsorption? काय हीट ऑफ ऍडसॉर्प्शन म्हणजे काय सांगता येईल? हीट ऑफ ऍडसॉर्प्शन म्हणजे what is heat of adsorption? Am I audible?
Yes, ma'am.
मग हीट ऑफ ऍडसॉर्प्शन ची डेफिनेशन सांगा मला.
Heat is evolved or liberated within a gram
What is heat of adsorption? Heat evolved. Heat evolved when काय
1 gram gas.
1
1
gram
gram
mole
gas.
of a acid adsorbed on the solid surface.
Surface.
1 ग्रॅम मोल गॅसचा सॉलिड सरफेस वरती ऍडसॉर्ब झाल्यानंतर जेवढी हीट इव्हॉल्व केली जाते दॅट इज नोन ॲज द हीट ऑफ ऍडसॉर्प्शन. 1 gram mole of carbon dioxide means how many grams of carbon dioxide? 1 gram mole of carbon dioxide means how many grams of carbon dioxide? 1 gram mole of CO2. Gram mole means, what is gram mole? One mole of CO2 means how many gram of CO2? काय तुम्ही विसरताय पाठीमागचं सगळं. CO2 चा मोलिक्युलर वेट किती? कार्बन डायऑक्साइडचा मोलिक्युलर वेट सांगा मला.
44.
किती?
44.
40. बरोबर आहे,
44.
बोला. कार्बन किती? 12.
12.
आणि O2 32. दॅट इज 44. मग 44 ग्रॅम of CO2 means 1 gram mole of CO2. When its molecular weight is expressed in gram, it is 1 gram mole. 1 gram mole of CO2 ज्यावेळी ऍडसॉर्ब होईल सॉलिड सरफेस वरती, इन केस ऑफ द कार्बन डायऑक्साइड adsorbate आणि सॉलिड सरफेस, कन्सिडर एनी सॉलिड सरफेस, that is the charcoal, alumina, silica, or finely divided nickel or platinum. When that much amount of gas is adsorbed on the solid surface, the amount of heat evolved during this adsorption process is known as the heat of adsorption. समजलं heat of adsorption म्हणजे काय? समजलं का नाही समजलं? हा
Yes,
Yes,
ma'am.
ma'am.
येतं आणि फक्त एक दोनच विद्यार्थी बोलतात. हा मी काय सांगितलेलं आहे तुम्हाला बघायला? व्हाय ऍडसॉर्प्शन इज एक्झोथर्मिक. पुढच्या लेक्चरला मला सांगायचंय व्हाय इट इज एक्झोथर्मिक. Thus, we have seen about the what is mean by surface. अशा प्रकारे आपण या लेक्चरला सरफेस केमिस्ट्री अगदी तुमचे ऍडमिशन अजून सर्वांचे होत आहेत. त्यामुळं हा पाठ तुम्हाला जनरली मला वाटतं 12th स्टँडर्ड मध्ये पण थोडासा झालेला आहे. म्हणूनच सुरुवातीला हा टॉपिक घेतलेला आहे सुरुवातीला, कारण तुमची विद्यार्थी संख्या अजून आपली बरीच आहे आणि बऱ्याच जण अजून ऍडमिशन चाललेले आहेत. त्यामुळे लवकर ऍडमिशन कन्फर्म करा. We have seen about the surface. Surface म्हणजे काय हे आपण पाहिलेलं आहे. Surface is the interface between the two media is known as the surface. We have seen about the history of the adsorption, that is since from the long time animal charcoal was used for decoloration, and that is it removes the coloring impurities from the sugar solution. And nowadays various substances having charcoal like properties, that is finely divided nickel, platinum, alumina, silica gel are used. And what happens, that is how it removes the coloring impurities from the sugar solution or unwanted matter from the solution. What happens actually when we add this substance in the solution, that unwanted substances are adhered on the surface of that substance, and there is the accumulation of that substance on the surface, that is known as the adsorption. म्हणजे चारकोल हा जर शुगर मध्ये ऍड केला शुगर सोल्युशन मध्ये, तर शुगर सोल्युशन मध्ये जे अनवॉन्टेड सबस्टन्सेस आहेत, कलरिंग इम्प्युरिटीज आहेत, या कलरिंग इम्प्युरिटीज अनवॉन्टेड सबस्टन्स हे चारकोल पावडरच्या सरफेस वरती अक्युमुलेट होतात. दॅट इज नोन ॲज द ऍडसॉर्प्शन. म्हणजे ऍडसॉर्प्शनचे डेफिनेशन आपण पाहिलेले आहे. इट इज द सरफेस फिनॉमिना अँड इट इज द accumulation of the another substance on the surface of other substance, collection or accumulation of the another substance on the surface of the other substance, and that is known as the adsorption. Adsorption म्हणजे काय हे आपण पाहिलं. नंतर मेकॅनिझम ऑफ द adsorption पाहिलेलं आहे. मेकॅनिझम ऑफ adsorption मध्ये आपण पाहिले की कुठलाही मॅटर ज्यावेळी आपण कन्सिडर करतो त्यावेळी त्याच्यातले इंडिव्हिज्युअल युनिट्स म्हणजे काय, तर स्मॉलेस्ट युनिट. स्मॉलेस्ट युनिट सबस्टन्सचे कोणते असतात, तर ऍटम्स, आयन्स और मोलिक्युल्स. आणि हे स्मॉलेस्ट युनिट जर आपण कन्सिडर केले आणि बल्क मध्ये सबस्टन्सच्या कन्सिडर केले, तर बल्क मध्ये या युनिट भोवती नेबरिंग सेम युनिट्स असतात आणि दे एक्झर्ट द फोर्सेस ऑफ अट्रॅक्शन ऑन ईच अदर. Such forces are known as the cohesive forces. आणि हे cohesive forces सर्व बाजूंनी सारखेच असतात. We say that these forces are satisfied forces, these forces are balanced forces. But if we consider the molecules or units at the surface layer, there are not same units, same molecules or same atoms of that substance on the surface, as the surface of the substance is vacant, and therefore at the outer part of that substance their valencies remains unsatisfied, their forces are not balanced. Such forces are known as the residual forces. आणि मग या सरफेसच्या कॉन्टॅक्ट मध्ये अदर सबस्टन्स ज्यावेळी येतो त्यावेळी these surface molecules try to satisfy their forces, try to satisfy their residual forces, their residual valency, and therefore they attract that another substance on its surface and hold that other substance on the surface. So we say that there is the accumulation of the another substance on the surface of that substance, and it is known as the adsorption. That is the mechanism of the adsorption. We have seen the examples of the adsorption, that is in the methylene blue. When we add the charcoal powder, after some time we observe that color of methylene blue solution becomes faint. Why it happens? That is, charcoal powder adsorbs the methylene blue molecules on its surface. Adsorption takes place and therefore the solution becomes faint. If we see the absorption, that is, if we dip the sponge in water, water penetrate in the body of the sponge, it is the bulk phenomena. Means if we have to consider the difference between adsorption and absorption, these two phenomena are sorption. दोन्ही phenomena sorption. But these two phenomena are quite different. That is, the adsorption is surface phenomena, while the absorption is the bulk phenomena. From that, we have seen the figures for the adsorption and absorption. That is, adsorption जर आपण पाहिलं तर त्याच्या फक्त सरफेसला दुसरा सबस्टन्स ॲक्युमुलेट होतो, पण ऍब्सॉर्प्शन मध्ये दुसरा सबस्टन्स ज्यावेळी त्याच्या कॉन्टॅक्ट मध्ये येतो तेव्हा तो त्याच्यामध्ये पेनिट्रेट होतो, त्याच्या बॉडीमध्ये पेनिट्रेट होतो and gets uniformly distributed within the body of the other substance. म्हणजे युनिफॉर्मली डिस्ट्रीब्युट होतो फक्त, परंतु ऍडसॉर्प्शन मध्ये फक्त तो दुसरा सबस्टन्स हा सरफेस वरतीच ॲक्युमुलेट होतो, म्हणजेच युनिफॉर्मली डिस्ट्रीब्युट होत नाही. Also we have seen about the difference between absorption and adsorption. Absorption आणि adsorption मधले डिफरन्स आपण पाहिलेले आहेत, त्याची एक्झाम्पल्स पाहिलेले आहेत. And we have seen the different factors which will affect the adsorption. Also these are known as the characteristics of the adsorption. अजून 3 फॅक्टर्स आपले राहिलेले आहेत, ते आपण नेक्स्ट लेक्चरला बघूया. तुम्ही काय बघून यायचंय? Why the adsorption is exothermic process. Then send me a screenshot on our WhatsApp group. If you have any difficulty, then ask me. काय डिफिकल्टी आहे का? काय डिफिकल्टी आहे का तुम्हाला? जो पार्ट आता मी आहे त्याच्यामध्ये काय डिफिकल्टी आहे का? बोला.
नाही.
नाही ना? एकच जण बोलते. काय नाव तुझं? एकच विद्यार्थी आणि एकच विद्यार्थिनी बोलते, बाकीच्यांना डिफिकल्टी आहे का?
नो मॅम.
नो.
आवाज येतोय ना सगळ्यांना?
हो.
येस मॅम.
काय डिफिकल्टी असेल सांगा. Thus, we have seen about this part. Now our time is over. Let us see other factors in the next lecture.